Hey, what's up? My name is Jake Torres, and so I'll be going through my programming assignment 2. Let's start with the classification example. Sweet. So here's an example of a fully grown decision tree. Here's an example of a sample outputs from one test fold and the class labels. And then here is the pruned classification tree. Let's move on to a regression example. Cool. All right, so here's the fully grown decision tree. Here's a sample output from one test fold, all the features and then the responsive labels, and then here's the final pruned tree. All right, let's get into my equations. And we'll come back to this. All right, so it defines the gain ratio. It basically just found the entropy of a specific feature and the gain as well. And I divided the gain by the entropy. Information gain was calculated by calculating the entropy using this equation here, and expected entropy using this equation here, and then subtracting the expected entropy from the entropy. I guess in terms of entropy, the entropy is basically just the sum over all of the values in a feature, and then you take the sum of the subset of data in a partition that reaches a specific branch over the total instances in the partition, and then times log base 2 of the subset of all data in a partition that reaches the branch over all instances in the partition. Expected entropy is a little different. This is basically just the sum for each value in a feature, basically the sum of an individual value divided by the total number of instances in a partition multiplied by the entropy of that feature value. Let's move on to mean squared error. So mean squared error here, we take the sum of the difference between a mean response value of a partition and the predicted response value divided by the total number of instances in that partition. As you can see, here's my calculations or my equations. Now let's move on to predictions or a decision being made to prune a tree. And here's a good example. Okay, so let's see. When locating each of the tagged internal nodes, we found this internal node here with the feature value of education spending, and actually pruning at this node improved the accuracy. So pruning of the previous feature above, which was educational spending, was made permanent, and you can see the improvement was made permanent below here. Let's go into traversals. I have to uncomment some things. All right, let's do a classification example for traversal. Here's the example. Okay, this is a long traversal. Okay, so we start at this specific row. Yeah, so we have all the feature values, the class label. We begin at this current node. We move on to this next current node, to the next node, and then we finally reach a leaf node, and the class is Democrat, so the prediction is made to predict this row as Democrat. Let's do regression example, and then we're done. Cool. So we're given this row to begin with in the data frame. We traverse through all these nodes until we reach a leaf node with the response value of 1.09. So the prediction is made as 1.09, and that's that. Thanks for watching.